Hello, this question is from GATE 2018 and this question is from the domain of nuclear and particle physics. This question is given in the format of numerical answer type or NET question. The question states 4 MeV gamma rays emitted by the de-excitation of 19F are attributed, assuming spherical symmetry, to the transition of protons from 1d 3 by 2 state to 1d 5 by 2 state. If the contribution of spin orbit term to the total energy is written as C times expectation value of L dot S, the magnitude of C is dash MeV. So let us solve the question. So we know that the total angular momentum is the vector sum of orbital angular momentum and spin orbital angular momentum. So first let us multiply this expression, above expression, with itself. So we will get j dot j equals to L plus S dot L plus S, which will give me j square equals L square plus S square plus twice L dot S. Okay, so we will see that twice L dot S will be equals to j square minus L square minus S square, and I will get L dot S as half of j square minus L square minus S square. So the expectation value of L dot S will be half of j times j plus 1 minus L times L plus 1 minus S times S plus 1. So now we are given that the proton, first thing is given that the proton transition is from 1d 3 by 2 state to 1d 5 by 2 state. So let me consider 1d 3 by 2 state as state 1 and 1d 5 by 2 state as state 2. Okay, so here you can say j1 corresponding to state 1 is 3 by 2 and j2 which corresponds to state 2 is 5 by 2. Now for both of the states are d states, so state 1 is d 3 by 2 state and state 2 is d 5 by 2 state. So for both of the states, L1 for state 1, L2 for state 2 will be equal, and let me consider this thing as L and this value is 2 for d states. L equals 2, and as the particles are proton, so S1 corresponding to state 1 is also equal to S2 corresponding to state 2. Let me consider this constant as S, which is half. Okay, now notice that, or I can directly say that here J1 equals to L minus half and J2 equals to L plus half. So the next thing that they have given here is that the de-excitation energy of the gamma rays is 4 MeV. So the de-excitation energy of gamma rays due to this transition is, let us consider it as delta E equals 4 MeV. Next thing is the contribution of spin orbit coupling term to the total energy, uh, which is, let us see as E suffix SOC is C times expectation value of L dot S. So the energy difference, so we can write the energy difference delta E in form of this spin orbit coupling energy for this transition as C times L dot S for state 2, which is J2 equals to 5 by 2 minus L dot S for J1 3 by 2. Now we have seen that both L1 and L2 and S1 and S2 pairs are same. So we can directly reduce this thing as the J2 times J2 plus 1 minus J1 times J1 plus 1, because other terms will be directly cancelled. So this will give me C times J2 is 5 by 2 times 7 by 2 minus J1 is 3 by 2 times 5 by 2, which is C times 35 by 4 minus 15 by 4. So this is minus 15, which is 20. 20 by 4 is 5. So this is 5C. So delta E equals 5C equals 4 MeV. I think, oh, there is a half is there, so it should be C by 2. It should also be C by 2, C by 2, C by 2. So this is 5C by 2. So this will make the calculation as delta equals to 5C by 2 equals 4 MeV. So this implies that C equals to 8 by 5 MeV, which is 1.6 MeV. So answer is 1.6. Thank you.